All right, we're going to get started. This talk is on the road to TDE, and it's going to include a lot of non-TDE things, and it's just as a kind of progression towards TDE and things that we're thinking about. So I'm, I guess I can go over. I'm Stephen Frost. I'm the CTO at Crunchy Data. I've done some stuff in Postgres. I'm
David Christensen. I'm a principal database engineer at Crunchy Data. I've been using Postgres since version 6.5, so about 25 or 20 years, I guess, at this point. I've done some consulting with various pieces, and lately been working on this project with Stephen. So.
All right, so let's talk a little bit about transparent data encryption real quick, right? What is the point of it? So the idea here is that we're going to, encrypt all the data that gets written to disk, right? Without requiring any application level changes. So there's different proposals out there, and there's a proposal out there right now from Peter Eisentraut that I think is a great idea, which is to do client-side encryption using a special column encryption, column data type for encryption. But that is something that's going to require application changes, right? And that's something that not everybody's going to want to have to deal with. But the whole point of TDE is that it addresses a lot of those kind of data at-rest attack vectors. And it doesn't depend on external solutions, doesn't require you to go do a bunch of other setup. There are other solutions out there. There are block level solutions out there like DMCrypt or other things. Your storage might provide some kind of encryption. And sometimes those work just fine, and sometimes those answer the mail when it comes to this. But there's a lot of cases out there where, for whatever reason, those are not options that are available to you. And you still need to be able to have that encryption in order to be able to tell your auditors that, yes, our data is encrypted, right? And there are real attack vectors that it does address, too. It's not just about, these ideas of, well, if you did it at the Linux kernel and you did it below that, well, that's good. But there are cases where your backup tool is kind of a classic example. If you can have a backup that can run without having to have that backup tool have the encryption key for the database, then you don't have to worry about that backup tool being, or that backup account being compromised, right? Or at least it's less of a risk. And that's something that something like a DMCrypt isn't going to help you with, right? That's a pretty common ask, actually, and we see it on the lists pretty regularly these days. So that's a lot of what the justification and the reasoning behind this is. So what are the goals of this particular TDE effort? Because we don't want to get ourselves too crazy, although some of the things I'm going to talk about are already really crazy. But at least the goals right now are we want to encrypt all user data, right? And when I talk about user data here, what I'm saying is, I might call it principal user data, right? This is data that the user gave us. It's not metadata, it's not transaction information, right? It's not anything else. And I think something that's really important here also is optionally with authentication, right? So what is authentication? So people think about encryption and they're like, well, I can encrypt this block and nobody can then read it, right? Well, that's true, but it can still be modified, right? And yeah, when you modify it, it might end up looking like garbage or it might not, right? It really depends on exactly what happens, but there's nothing in the encryption systems that have any kind of check to make sure that the encryption, that the block wasn't changed from when it was encrypted, right? Not without having authentication, right? That is what authentication is in the crypto world, but authentication requires an additional tag to be added, right? And I'm going to kind of go into that a bit more here. But the idea here is that we want to encrypt the heap, indexes, things like statistics, temporary tables, temporary files, like what gets generated through logical decoding, and the write-ahead log, right? Now, I'm leaving a bunch of things out of here, right? Because they're not actually things that are user data today, right? So talking about like PGXAC, like the transaction log, the subtransaction log, the commit timestamp manager, multi-exact, like all of these things today at least are not things that I was thinking about being within scope of TDE, right? Because I figured they'd be kind of hard. Then Heap came along and wrote a patch that just made all of those use the page format and put them all, with the idea of having them all inside of shared buffers. And if we just do that with the patches that we've got for TDE, it would just work, right? Because Right now, the way we have the patches implemented for TDE is that anything using the page format is going to get the encryption with it, very similar to how checksums work, right? Same kind of thing. And so while I have this as a TDE non-goal, I'm very interested in that effort, and I think it would be great to get all the SLRUs inside of the shared buffer cache, and also to be able to then have all of those use the page format, because if they're using the page format, all of this other stuff that I'm talking about is going to kind of come along for free practically. So, yeah. Is var? Wall. Yeah, wall is encrypted, yeah, in what we've got. Yeah, wall is encrypted. Yeah, because wall does have actual user data in it. So we would want to make sure that the write-ahead log also gets encrypted. Sure. Yeah, sorry. This transaction log is PGXAC. This is the SLRU that's talking about like what transactions have committed or aborted or whatever, right? C-log, as we used to be. But anyway, that's what that is. But again, if those changes to actually pull all of those into the shared buffer pool get in, we'll just get it for free, right? So the idea, we started looking at these different things, and we kind of came up with this idea of how to kind of build this all forward, right, to get to a point where we can do this. And I'm gonna kind of go into each one of these. But first thing is that if we want to find more space on the page, we're going to need to make some changes to things, and that one of those is essentially a runtime block size capability, right? And then have a reserved space on the page, and then introduce this concept of page features. And then we also need to have a unified way of dealing with temporary files. And then finally, once we get through all of that, then we can have this key management system that we can add in. And then finally, we can do TDE on top of all of that. So I'm going to kind of walk through what each of those looks like in what we're thinking about. All right, so first idea here is, well, let's specify the block size at initdb time. So let's go through everywhere that we're using block size today, which is all currently compile time, and instead have this idea that we're going to have per build of Postgres some kind of idea of, we'll have a max a block size that particular build supports, and then we'll have what is the currently running block size, right? When we were looking at this, is introducing this idea of a reserved page area basically touches a whole bunch of the same places that having a runtime block size would also touch, right? And this also gets us possibly closer to the idea of being able to have multiple block sizes supported inside of a given running postmaster, possibly using, as I was just talking about earlier, different shared buffer pools as an idea, right? It's a possibility. At least right now, that's not something we're trying to figure out a way to do. I think we're just interested in, like, if we make block size no longer compile time and make it something that you could have one set of binaries that runs with anywhere from 2K or 4K or 8K all the way up to 32K blocks. That could be very interesting. I think there's definitely a lot of potential users out there of something like that. Because I do know that we do have people who run 32K block sizes, right? It's not that uncommon, but it requires a separate build of Postgres today to do that. So this is, if we're touching all of the same area, let's do that as a separate thing first and see what happens, right? And get a feel for it. Yeah, I mentioned this already. You introduced the idea of a max build, max block size for a given build, because that's what we're going to need for a lot of structures and other things that require that some kind of compile time size, things that end up on the stack, although some of those should probably not be there. And then introduce this kind of additional function to introduce what the current block size is. So then we start talking about, okay, well, once we've got that, now everything is kind of going through this page structure, but the page structure can vary in size. We can have this way of grabbing a portion of that page for our own use, right? So this is the idea of a reserved page area. And we talk about this as post special. So there is a special area on a lot of different pages. The Heap doesn't, but a lot of the indexes have the special area. We need this to be after that, right? We really need to have it be something that is well known, specifically for being able to do authenticated encryption. And by well-known, I mean every page has to have it in the same place because we're going to need that tag in order to decrypt the page. So this makes the new page layout look kind of like you have a page header, maybe you've got line pointers or not, maybe you've got tuples or not. Then you have possibly this special area, and then finally you have this reserved page area at the end. Again, authenticated encryption is something that's going to require knowing where the auth tag is on a given page in order to make this work. So this introduces the idea of PageGetContentSize, right? So you have PageGetContents and then PageGetContentSize, right? So that users of this structure know how much room they actually have to work with on a given page, right? And that getContentSize will account for the page header, whatever the current page size, and then also account for the reserved page space. And then, yeah, for certain things, we may also need like a max possible content size, right? That's something else that we're talking about as possibly needing. And then you get into this idea of, okay, well now we want to talk about a page level feature flag, right? So this idea here takes one feature or one flag, right, page level flag, and uses that to indicate whether or not special features are enabled on this page or not. If they are, we turn the 16-bit checksum field into a field of what features are enabled for this particular page. Do we not have enough flags left in the page header for, I don't know how many different features we're going to have. So this approach takes, for one thing, the 16-bit checksum is useless if you've got an authentication tag, right? If you're doing encryption and you've got an authentication tag that you're using for authenticated encryption, you have zero need for the checksum field, right? So part of it was, yeah, it'd be nice just to be able to get some of that back and do something with it, right? So that's part of it. The other part of it was we wanted a simple feature to go with this, not full-out TDE authenticated encryption, but a simple feature. And the simple feature that we came up with was use a better checksum, right? And again, if you're putting a better checksum into the reserved page area, you don't need the 16-bit checksum field anymore. Maybe maybe other things could go into this checksum field in the future, rather than having it. We don't need to dedicate it all 16 bits to this, right? I mean, we could do whatever we want with it, essentially.
It's also something that we could reserve the highest feature flag to be, hey, there's more features, because we have the ability to allocate space. So at that point, extended features, and then you get another fit flag of whatever size you need. So the idea is 16 seems like a good amount for now.
Yeah, it was just that right now we only are using, I think, 2 bits of the 8 bits of the page header language.
Yeah, I mean, we could do that instead. This is just what we ended up coming up with for now. Again, a lot of this is very much kind of work in progress. Like, let's see what happens, and let's see what we end up doing, and I don't know if we can even make it work, right? Yeah.
The map is only going to be useful if you're decrypting the value. And there are going to be use cases where you're going to need checksum to checksum the encrypted value without the convenient verification.
I don't know. I guess my feeling is the answer to that is no, that you aren't going to need like a separate checksum to check to see if the data is valid or not. Yeah, the decryption, but I mean, encryption and decryption is awful fast these days. I'm not really super worried about that aspect of it. I mean, yeah, you could read the page and calculate the 16-bit checksum on the encrypted page and see if that worked or not, I guess. But so in that case, the only one I can think of would be something like a backup tool could do that. Which, yeah, maybe that would be interesting. But again, I guess my only concern is I also don't want to get shot down for using up too many of those few flags. And making this available is another approach. But yeah, you're right, we could do that instead, sure. So yeah, the idea here is, first idea would be, once we've done all this other work, then we can go and add in this ability to have an enhanced per page checksum, which is a separate, independently useful feature and capability that is not involved with TDE or with authenticated encryption or anything like that. And then, yeah, you could also introduce other checksum options if you want. We could implement 5 different ones if we wanted to, although I don't think we would want to. Yeah, we'd stick this into that kind of reserved page area at the end, implement it as kind of an initial feature. I think I talked a little bit about this already, but authenticated encryption requires having that additional space per page for the authentication tag, and really does kind of get rid of the need for a stronger checksum. And also with the authenticated encryption, we can have additional authenticated data, right? And what this is, what we'll typically use this for would be things like the rel file node. We'll put the block number in there, and it's just any other data that we want to include that gets hashed in with that authentication tag with the encryption key that you can then use to verify that someone didn't move a block from one place to another or rename files on the file system underneath of you. One of the things that was nice was PG upgrade was changed so that it doesn't go and end up having a whole different set of files on upgrade anymore. So that would be a requirement for having the rel file node be included in this. And then I just kind of threw out other ideas, right? These are not things we're even working on, but these are other ideas I've heard from people that have been like, well, this would be interesting if we had more space on the page, which would be like a page level XMin, right? So you could possibly have tuple headers be smaller. You'd always still keep space for the Xmax, but then you could possibly fit more tuples onto a page as an idea, right? But this requires additional space for one. Yeah. Crazy, right? Well, so it would only, so you'd have to have, the tuple header would have to have a way of, you'd have to have some indication on a per tuple basis as to whether it's using the page level XMin or not, right? So everything that's doing an insert inside, if you're doing a big bulk insert, right, or a big copy, those are all going to have the same XMin, and they're all in for every page where it's able to. But again, this is just really just pie in the sky ideas of if we had more space on the page, what could we do, right? And I do think it's a topic that I didn't come up with this one. Somebody else mentioned it to me as an idea, right? So you do a bulk copy, you have a tuple header that can be variable in size, and you have a way of referencing whether this particular tuple is using the page level XMin or has its own. What's that? Yeah, maybe, yeah. I don't recall who, I'm sorry. Certainly 64-bit XIDs is another one, right? This requires additional space in order to have a horizon or the top half, right? But I do think using reserved page space and actually just having a space for this would simplify that effort quite a bit. We looked into it a little bit. It looked tricky.
The final product would have been fine. I think it's the transitionary state that they had with the approach that the existing patch used would it'd take a little work to get it going. But
yeah, so this doesn't help at all with the issues around too old XMin or too new Xmax. Although one thing I did think about here of, if you had a way to have a variable tuple header, maybe you could actually just have a table space that's got 64-bit XID tuples. I don't know. Separate idea. All right, moving on to kind of access for temporary files, access for non-heap, non-index. Right, we have a few different ways today that are being used for writing kind of non-heap files, and it'd be great to kind of bring those all together, make sure they're all consistently using VFDs, because some of them weren't until more recently. And that would then also give us one place to introduce new features, which doesn't have to be encryption, right? It could be checksums, maybe it could be compression, right? But also hopefully encryption. And I do think this is important, right? Because a lot of those things have user data in them, right? Temporary tables have user data. And so that would be an example. Now, temp tables in particular already use the page structure. So the fact that they're already using the page structure and going through that means we don't really have to do a lot to have them be able to be encrypted. things like queries, when they spill the disk, right, they've got user data. We did have an idea here that John's actively looking at of like, what if we use the page format for that too, right? Leverage that existing code that we already have for pages, could add the checksum in as it as well, and then we could then just have this page feature capability associated with it as well. I've also got ideas in my head that one of these days maybe we'll have like a big shared memory area for work mem, right? Rather than having it be per backend, right? Because having it be per backend means that you have no guarantees of how much memory is going to get allocated. You have no way of having any control over that. And we've seen problems with that. And it also means people end up having to have a whole bunch of memory out there that, well, maybe it'll get used for this, maybe it won't get used for this, maybe it'll just have really old kernel file system cache data in it, right? It's not very helpful. But it is a thing that we end up having today. Logical decoding is another area that would have to get adjusted. Again, maybe we could use the page format and leverage that existing code and use page features there. Kind of the idea, though, is bring all of those through kind of the same way. Statistics is another thing that's got another way of writing things out, right? Like if we had all of these going through one central area that had this concept of, well, you get this amount of room to do your thing in, and then if you need more, we'll give you more, but then we have our own stuff that goes around it for doing checksums, for doing encryption, for doing authenticated encryption. Of course, other ideas around statistics, like moving them into regular tables and things, but that's a whole different discussion. And then, once we've kind of gone through all of that, then we get to things like the key management system, right? So in order to have encryption be in the database, we're going to need some kind of key management system because we're going to have multiple different keys, right? We're going to have multiple DECs, right, which are data encryption keys. And we've kind of talked through some of those ideas around what different data encryption keys we would have, but then we'd also need to have the actual user-provided key. So this is what would typically be called a KEK or a key encryption key. So you have the key encryption key is provided by the user. That is then used to encrypt all of the data encryption keys, which we automatically generate at initialization time. Now, some of those keys we may also generate at runtime, right? An example of this would be like temporary files or temporary tables. Those things that don't actually survive through a restart of the system don't need to use a long-lasting data encryption key, right? Those could use a separate per-run data encryption key that we generate at time of run, and that also means that it makes it easier for us to ensure that we don't end up repeating initialization vectors, which is an important thing, because you can't repeat the combination of a key and an initialization vector. If you do that with different sets of data, you can end up breaking the encryption, and that's not what you want to end up doing. But you could have an in-memory counter that all it's doing is going up and up and up, and then if you have a per-run key to go along with it, now you have a guarantee that you're not going to ever repeat it. Also, we want to eventually be able to get to a point where we're doing rotation of data encryption keys, or at least being able to use more than one data encryption key for particularly large systems. Having a KMS also allows us to do that. We're also talking about having a separate data encryption key for the write-ahead log. And there's also been people, it continues to be a question around this about having separate keys for different table spaces or different databases. And I think that there are some possibilities in there as for whether or not it's really going to solve the problem that people are thinking it's going to solve, which is principally, multi-tenancy where people bring their own keys. It's kind of a different question. But it's still definitely a topic of a lot of interest, is being able to do that with TDE. And that would also require a KMS. So, it's been a lot of work ongoing for a number of years. Been a number of commits that have already moved Postgres forward. We're looking at some other ideas for, as I mentioned earlier in this deck, of things that we're going to try and see what happens. But definitely the main components are having to have a KMS. We need to make sure the encryption of pages and the write-ahead log gets done along with these temporary files. But the initial target here is to have encryption of all user data, right? That's the big thing here. So how we do the heap and index encryption is, it's very similar to how we do checksums. We directly encrypt the page as we go to write it out, and that takes care of, a good bit of stuff. We do also have an option here of not changing the page format at all and just using XTS, and that's actually something that we have in a patch set as well. And then, building on top of the page feature work is the ability to have authenticated encryption with an actual authentication tag. And then currently using the LSN as the initialization vector, but that, as has been pointed out, there are some cases where that's not great because we may end up not changing the LSN but writing new data. So if, with the page feature capability, we could also have a per page counter that we use as the IV instead of the LSN at all, right? And then you can be assured that you're not ever going to repeat those. So it's just another way that another thing you could leverage the page feature capability for. And I'm sure there's other ideas. Like I'm sure other people have different ideas about, like, if we had a bit more space on the page, here's what we could do.
Well, you can just increment the LSN on the page every time you write out by one, assuming you're not going to be above the latest LSN.
But you.
Because then we just replay the wall record and that thing. But that's not different from how we do it. Right? We updated to the LSN of the wall record that we actually replay.
Yeah, we wrote the wall record first, so we have the LSN of the wall record, and that's what we put on the page. But we can't just like arbitrarily increase the LSN to not match that anymore.
The only thing that the LSN on the page is referring to is all the changes that have been made up to this point need to be flushed before I can flush it to this. That's fine.
I mean, I understand what you're getting at with that, that's how the checkpointer works, to make sure that it knows it can write these things out and make sure that we write the wall before we write that out. I'm not 100% guaranteed that you can just change it, though. If you'd like to propose that patch, I welcome it. Because if you solve that problem, that would be great. Then I don't have to worry about it. But either way, if we do need to have a separate IV or a separate, nonce on the page, using the page feature capability would allow us to do that. And then, write-ahead log encryption. So this, as I mentioned before, uses a different key from the heap and index, and it was included in the TDE patches posted. But do you want to talk a little bit about what you've done with the latest set? Because you did change some of that to use.
So,
yeah. I don't know if
that doesn't move. It's just environmental. Okay. Well, yeah. So the latest version that I've been working on includes GCM with authentication for the wall itself. So we do away with the CRC field in there, and we use an auth tag. So basically, since CRC in wall is meant to do kind of the validation of the wall records, it serves double duty in this case. So then we're able to kind of stream, replay. We chose to go the route of encrypting on a record-by-record basis, also using the LSN for the initialization vector.
In that case, it's fine, right?
Yeah, in this case, we know that's always increasing. Had to make a few changes to how things were going. There's a few places where it goes back, and it's unlike a CRC, which you can kind of do a little bit out of order, or if you're doing the validation of the things and then do the header next, we had to, I think, basically get to the point where we had the entire record written out in memory and then kind of do our authentication, because we're adding the additional authenticated data to the checksum at the same, or not the checksum, the tag at that point. But yeah, so this is working with a separate key, a separate encryption key, separate other pieces. It's proof of concept. It seems to work. It works with replication. Andres?
When you say wall data is encrypted, do you mean the record header is not?
The record header is not in the current setting. So the entire record header, basically the payload is encrypted at that point. Yeah, so Yeah, everything else except the record header is encrypted. So page images, everything else.
We end up putting. Did we put the actual do we put the header into the additional authenticated?
Yes, we do authenticate the header as part of that. So that was the piece I was talking about where you had to kind of do it in a different order.
Yeah, so we can validate that the record header hasn't changed at least, right, out from under us, because it's included in the additional authenticated data that goes into the auth tag for the encryption.
Yeah. Any other questions about this part? Okay.
Yeah, so there we go. Yeah, so I think I talked through this. Yeah, so talked earlier about just unifying the structures. Here I'm talking about, like, when we're doing encryption of temporary tables. I mentioned this kind of early on. We need to make sure we have a unique key plus IV, and so the idea here is that we'll generate a new key at cluster start for things like temp tables, and then we'll have some kind of increasing counter for the IV, maybe possibly tag on to the existing unlogged LSN, or we could come up with something new if we wanted. Either way is fine, as long as it is some value that we can make sure is always increasing and never repeats, so that we have that guarantee of a unique key with IV combination. Unlogged LSNs would work for this simply because even though they do possibly go backwards, if we're generating a new key on every start, it doesn't really matter if they move backwards a little bit, right? It's not really an issue for us. When it comes to encrypting query information that spills the disk, again, I like the idea of possibly using the page format for this. And then again, we can use as long as we have a unique key and IV, and queries in progress are all also temporary files, right? They're going to go away after restart, so they can use that same temporary data encryption key. When it comes to things like statistics, those are not temporary, right? We're going to have to actually make sure to encrypt those with a longer running key, and it has to be maintained across restarts. And we still need to have that encryption key and IV be unique, right? So some of the ideas we had about that is maybe generate the key during initdb, store that key in the KMS, and then use the shutdown LSN as the initialization vector as a possibility, right? In order to have that have a unique IV that we know every time. Yeah. So we already have XTS and GCM, right, as two different algorithms, and it's all pretty abstracted out. So in the event that you wanted to have a different encryption method, yeah. Yeah, so SIV isn't actually supported until pretty recent releases of things. I forget what version of OpenSSL, but it's like a brand new one. It's not really available, if I remember correctly. But yeah, which maybe is not an issue. I don't know, but right, yeah, SIV is a possibility. So SIV is a kind of simulated initialization vector that you can use as an alternative to having to keep track of an initialization vector. And yeah, that's something that we've talked about and thought about, and maybe.
It's a poor man's version, I think, for V1. You'd have a separate cluster of the unit, and then create a replica via base backup, and change the key, rekey as it copies over. I think is what we've talked about there.
Yeah, with something like XTS, you can do that. You can do essentially a backup that does encryption as it goes, and you could have an encrypted cluster with XTS running with an unencrypted Postgres that's actually feeding it write-ahead logs that it is then replaying, but you can't do that with an authenticated cluster, right? Because the page sizes are not the same anymore. So yeah, talking about authenticated encryption again here, right? Like I was saying before, encryption alone only provides confidentiality. It doesn't provide any assurance that the data hasn't been changed, but that's really important to have, right? And that requires this tag to be stored. And so our approach is, having this reserve space, ideally be added onto every page so that we can do this. And we've got patches for that, and we're going to continue to work on it and continue to move down this road and see what we can do. And additional authenticated data. Yeah, so these are the things that we were talking about including. So rel file node, database OID, the cluster ID, possibly other things. There's no like real hard requirement to have a whole bunch of, to keep the set of data we put in this small, because it's just stuff that's getting included in the hash that's generating the auth tag. So we could certainly add in other things. And this, this kind of approach deals with, as I mentioned before, you don't want to have things move around. So you want like the block ID in there as well. And so that's basically what I had in terms of a slide deck. I do want to tell people that, we're happy to have kind of an unconference talk about this as well. Again, this is all, very much kind of work in progress, POC kind of stuff, especially around the page feature stuff. The XDS patches are, they work pretty well. I do think it would be better if we're going to go down this route to have in the write-ahead log, the GCM, as having authenticated encryption, and that's something that we can do without having to worry about changing page format, right? Because when you do a major version upgrade, you're going to get a new set of wall anyway. So that's something that I think we could do without it. So that's where the recent work around the GCM support for the write-ahead log came from, because the prior effort around that I think used CTR for encryption.
Well, and I think one of the other goals that we've had is to make it so both you can use this with or without any parts of the feature enabled. Also, being able to PG upgrade from an existing cluster with not breaking the upgrade path for people that don't want any of this stuff. So, obviously there'll be a little bit of overhead cost when it comes to going from compile time offsets to runtime offsets, and I think have to kind of do it to figure out what that is and what that looks like and whether the trade-off's worth it.
Yeah, that's definitely something that part of what we're working towards is exactly that question of, let's try this out and see what it ends up doing in terms of performance. Yeah.
Yeah, I don't really think it's wise to couple those two block size runtime change. That seems it's a huge product that will have pretty significant overhead.
Well, we're gonna see. we're gonna give it a go, and we're gonna find out, because I think that'll be at least instructive by its own right, just to find out. And I don't know, you're practically done already anyway, so.
Yeah, we've gotten this far.
Yeah, we've gotten this far, yeah. What?
How are you handling indexing?
Those are just normal relation files,
Yeah.
so they're the same. I think we said heap, we just mean any relation.
Yeah, heap and index go through the same page structure. They all go through the same page cache, and
Right, but if I'm looking up a value of index, it has to be deterministically.
So right, but what you have to understand is when we load a page off of disk, we decrypt it, and so in shared buffers, everything is decrypted. Right? Yeah. So you're not going to have to. Yeah, it's not an issue. Yeah.
For the key rotation, are you changing the actual DEK or just the key encryption key which is provided by you?
So right now, what there is support for is rotating the key encryption key. Having a KMS built in, though, is going to allow us to eventually have multiple decks. So I think the idea we had of around being able to have different decks, it would be like use the LSN, right? So you encrypt 100 terabytes with one, right? And once you get past that point, you decide, okay, now I'm going to come up with a new data encryption key to use for the next 100 terabytes. That part is not actually implemented yet, though. But at least that's what we've been thinking about. But what is implemented today in terms of key rotation is changing the key encryption key. That does work. Because that doesn't involve anything, but.
We don't need to decrypt everything.
Yeah, right, yeah. I mean, that is, yeah. There is definitely a concern that you don't want to have to, decrypt and then re-encrypt everything by rewriting the entire database. That's no fun. Right now, if you change the key encryption key, we do rewrite all of the data encryption keys because we have to decrypt them and then encrypt them, but that's a very small amount of data. Yeah, so it's not really.
Bytes, so.
Yeah, a couple hundred bytes, so it's not nearly as much of a concern or as much of an issue. Yeah.
How large is the expected XID required for instance, the authenticated pages?
So the authenticated tag, there's some literature out there from NIST that talks about how much data you can encrypt with a given encryption key and IV versus how big the auth tag has to be. I think right now we're using an 8-byte, right? We're using 8 bytes?
16 on the...
Or is it 16? Okay.
I think so. Yeah.
But
it's something that we can, there's a lookup table and it'll just do the right thing depending on what size it is. So we have some control over, I want to dedicate 8 additional bytes or 12 or whatever, and it should work as long as there's an encryption method that has that as one of the options. So.
Does that answer your question?
Yeah, I was just wondering what kind of sizes I would be expecting.
Yeah, I mean, probably 16 bytes would be.
Yeah, because most hashes that I see, which are definitely safe, which is what authentication also tends to, or wants to provide, are like 128 or 256 bits wide.
Bits, wait, yeah, sure.
Which is 16 or larger.
Yeah.
16 bytes, I think, is what we're doing right now. So, yeah, the wall has 8-byte the auth tags because it doesn't need as much, basically.
Yeah, again, there's a.
Well, we limited it with both the 16 now, finally.
I think the concerns are just like reuse of the same key and IV. So I think, the wall is guaranteed only to be once. So it's more of just an authentication.
But yeah, again, there's paperwork out there, or there's publications by NIST on recommendations for that size, right? And they do allow you to have a smaller auth tag for a smaller amount of data. But we can always, depending on what people feel like, we could change it. With having these things be runtime, you could also just like ask the user to tell you, right? If you want like extra strong, right? And it could just go add that much more space and add that much more to it. Same thing with, again, having like a per page IV rather than using the LSN because of the risk that the LSN might not be unique, right? So if that's a concern, we can add a page feature that just says, okay, well, we're just going to have a counter, or just have that be the default, right? Yeah.
Other than having a built-in KNS, are you planning to run support for calling APIs for internal KNS?
I definitely think that's something that we would want to do eventually. Being able to have the ability to go fetch a key from a remote system using a known standard protocol, because I know they have them now for that. Yeah, I think that would certainly be a good thing to do. And so I don't think it needs to be like in the first patch, but sure, yeah, I think that would be a good addition, so that you could fetch the key encryption key from a vault or something.
Yeah. Well, the key encryption key right now, it just calls a shell command that returns the key encryption key. So if you're just talking the KEC itself and not the DEX or anything, and like doing your own independent key management, if you're just talking that should be supported now, as long as you write the program. So.
Yeah, I mean, yeah, you'd have to. Well, most of those vaulting tools do have like a command line tool that you can use to get it back pretty easily.
Very much like archive command or whatever. So it's
Yeah, I mean.
Can be fragile. Okay.
Yeah. For my 2 cents, I actually think it would be better for us to support the actual like standard to be able to go fetch it ourselves rather than having to make people write shell scripts, because it's not a great API, frankly. It's not a good user experience at all, having to write shell scripts and having to drop shell scripts on all your different database systems to do this.
But for an MVP, that's...
Yeah, right. For right now, we don't have anything but the call out to the shell command. But yes, I think it would be a good feature to add.
Right.
Other questions, other comments? Awesome. Well, again, unconference tomorrow. Come and we'll talk more about this kind of stuff probably. Or just come and talk about whatever else you want to talk about. All right. Thanks, everybody.